Hello again. We're back for the lecture for Chapter 5, Section 1. And I left off the last time, oopsie, hey, come back, with this little table here. And it occurs to me it would probably be a good thing to actually go to all the trouble to make the tables. So let's do it. So the good news is that if these are using the notes, you can actually just copy and go to the notes and paste it in. If you did it right, which, there's no guarantee. All right, there we go. And I'm just going to make these as wide as I need. Cool. Okay, so remember from the Excel tutorial videos, if you've watched them, but you don't need to have, I'm going to take, let me just show you what I just did. I'm going to take cell B2, which is this guy. I'm going to divide it by B5, but I give B5 the $ symbols. That way they won't change when I drag it down. Actually, I'm going to double click it. There it is. And it fills in the rest of the column. So there's the relative frequencies. So my relative frequencies are 0.5, call it 510, 0.510, come back, 0.210, and 0.280, 0.210, and 0.280. All right, so we did that. Find the relative frequencies, check. What is the probability of selecting a brown candy? So if you reach into the Reese's Pieces bag, you're going to expect brown candies to show up 28% of the time, right? So the probability answer for this one is 28%. What is the probability, why is the probability above found to be empirical? Well, I kind of skipped over that. So let's go back and look at it. Empirical probabilities are probabilities that you found from probabilities that you find from research or experimentation. In other words, it's a process you can repeat and repeat and repeat. So you've already learned about this because all the relative frequencies that we found in Chapter 2, they're all in many ways empirical probabilities, right? So empirical probabilities just means you find out how often event E occurred and you divide it by the total. So for us, for example, you reach into a bag, you grabbed an orange candy 80 times, and the yellow candy 33 times, a brown candy 44 times. So the experiment of reaching into the bag and getting out a candy was repeated, what was it, 157 times, right? So out of that 157, how frequent was brown? Brown was 44 out of 157. So if you wanted to, you could say it that way, 44 out of 157, which is 0.280. All right, so it's empirical because you couldn't go figure this out without opening a bag of Reese's Pieces first, right? Because it came from experimenting and counting an actual bag of Reese's Pieces. Okay? So when it comes from something you're actually experimenting with and counting it, that's empirical. Now, of course, it doesn't have to be you doing the counting. It could be somebody else. But by the above table shows a probability model. Well, probability model has to follow these rules, i.e. every probability, oops, sorry, I don't want to underline that. Every probability was between 0 and 1. The probabilities total to 1. Right? They add up to 1, that column. Done. Now, classical probability. Classical probability is based on its gambling probability. So empirical probability is like from data. So empirical probability is like the more scientific probability, and classical probability is the gambler's probability. So it's probability that you can figure out just by the rules of the game, but not actually have to conduct an experiment on. So it came out of gambling ideas. Of course, it could get expanded past that. But when you're thinking of dice and cards, that kind of thing, poker, you're talking about classical probabilities. They were all, this is where the rules of probability came from. Was back in the day, mathematicians had to make a living, and so they figured out, a couple famous ones figured out the rules of probability and didn't tell anybody, and then used it to bilk people out of money for years. All right, so I'm going to be back. I'm going to have to make this tree diagram on a computer, and that's going to be interesting. So I'll be back here for the next video to start with classical probability.